Good morning, kids. Today you will learn the different chemical properties of materials through fun activities. In this lesson, you will, first, identify the chemical properties of materials, second, describe the chemical properties of materials, and lastly, determine the practical uses and applications of materials based on their chemical properties. Compare the garden spade and the shovel in the picture, kids. What do you notice? Correct, the shovel, which is made of iron, is rusty, while aluminum spade is not. Did you know that rusting is a chemical property of iron but not of aluminum? The chemical properties of materials can only be observed when they undergo a change to become a new kind of material. The reddish-brown rust is a new material different from iron. A chemical property is as characteristics of a substance that describes how it undergoes chemical changes or reactions with other substances. To observe a chemical property, we need to look for a chemical change. A chemical change happens when a material changes into a different material. Let's perform some activities to learn more about the chemical properties of materials. Let's begin with experiment number 1, but first, let's review our safety precautions. 1. Put your safety goggles and gloves to protect your eyes and hands. 2. Always have adult supervision when using fire, vinegar, and other chemicals. 3. Have appropriate fire extinguishers readily available in your laboratory, placed strategically in easy accessible locations. 4. Perform this activity in a well-ventilated area. Here are the materials in our experiment. Here are the procedures. First, create a table in your notebook. Write your observations in the appropriate column for each of the materials that you will burn. Two. Place the lighted candle in a metal can. 3. Carefully hold one material with the pair of tongs and set it on the candle flame. 4. When the sample material catches fire, carefully take it out of the flame and observe any changes while it continues to burn. 5. Measure the time it took for the material to completely burn. 6. Examine what is left of the material. 7. Repeat steps 3-6 for each of the other materials. Answer the guide questions in your notebook. Now, kids, let us talk about the chemical properties of materials based on what you just observed. Chemical properties are observed when materials change as they come into contact with heat and other materials. Chemical properties help us understand how materials behave and react. Flammability is a chemical property of materials that easily catch fire like paper, cotton, and matchsticks. Ash is the powdery, grayish material left behind after something is burned. Ash is a new material that is very different from paper and wood before burning. Thus, paper and wood underwent a chemical change. Flammable are materials that easily burn. Example: fuels, coal, liquefied petroleum gas, LPG, gasoline, and kerosene. On the other hand, non-flammable are materials that do not burn. Example: metals like steel and aluminum. Let us investigate another chemical property. We can do this the fun way by inflating a balloon. But first, let's review our safety precautions. Make sure to put on the safety goggles to protect your eyes. Safety is important when working with chemicals, even with common household materials such as baking soda and vinegar. These are the materials we'll need for experiment number 2. Here are the procedures. 1. Pour vinegar into the empty plastic water bottle until it is about 1/3 full. 2. Carefully stretch the balloon and insert the end of the funnel into the opening of the balloon. 3. Put 2 spoonfuls of baking soda into the funnel. Shake the baking soda down into the balloon. 4. Remove the balloon from the funnel. Stretch the opening of the balloon over the mouth of the plastic bottle. Completely seal the bottle by pulling the balloon down over the bottle opening. Make sure that the balloon is hanging down to prevent the baking soda from falling into the bottle. 5. Make sure that the bottle is securely sealed. 6. Slowly lift the balloon and let the baking soda inside the balloon pour into the bottle. Observe what happens. Answer the guide questions in your notebook. In our experiment, kids, what happened when the baking soda and vinegar mixed inside the bottle? A chemical change happened. You saw bubble forming inside the bottle. This shows us that a new material was produced, a type of gas called carbon dioxide. This gas made the balloon expand. The chemical property shown by the mixture of vinegar and baking soda is called reactivity. Reactivity is the ability of a material to combine chemically with another, resulting in the creation of a new material. Baking soda and vinegar are reactive materials. Vinegar belongs to a group of reactive materials called acids, and baking soda is in a group called bases. Most acids and bases are reactive materials. When these reactive materials combine with other substances, they form a new product that can be dangerous to our health and even to properties. This chemical property is called toxicity. Some toxic materials are harmful, and some can cause damage to other materials upon contact, due to their reactive properties. However, some of these toxic materials are useful as cleaning agents. Muriatic acid, which is often used to clean bathrooms, is one example of a cleaning agent. Bleach, a base used in washing clothes, is another example. What about food waste and other garbage, such as plastic and metal scraps? They possess another chemical property that you probably often observe: degradability, specifically biodegradability. This property is commonly linked with animal and plant materials. Degradability is the ability of a material to break down or change into simpler ones over time. Specifically, biodegradability is the ability of materials to break down naturally with the help of tiny living things called decomposers, such as bacteria and fungi. Think about leaves falling from trees onto the ground. Bacteria and fungi break down the leaves into smaller and smaller pieces, and soon nothing is left. The leaves then change into nutrients that are harmless to the environment and beneficial to plants. Biodegradable materials such as food scraps break down quickly and turn into useful nutrients for plants. Think of the food scraps in your compost bin. Rotting and composting are forms of biodegradation. Plastics, in general, and metal scraps do not break down easily. They can pile up and lead to environmental pollution. Answer the guide questions in your notebook. Uses of materials based on their chemical properties. Flammable materials burn easily when exposed to fire. They are primarily used as fuels. Wood, petroleum, coal, and natural gas are used for cooking, heating, generating electricity in power plants, as well as powering various modes of transportation. On the other hand, non-flammable materials used as protective barriers against flames and high temperatures. They are applied on fire doors and used as fire-resistant components in cars and airplanes. They are also used in clothing for firemen, military personnel, oil and gas industry workers, and race car drivers. The use of non-flammable materials reduces the risk of fire-related incidents. Reactive materials such as some acids and bases are used in many ways. Example: vinegar, lemon juice, and Philippine lime, calamansi, juice are used to remove dirt from utensils. They are also used in food preparation, such as flavoring and preserving food. Reactive materials also play an important role in the production of medicine. Baking soda and baking powder react with acids and other ingredients to make cake, breads, and other pastries rise and become fluffy. Another example is yeast, a microorganism that acts as a reactive ingredient in baking bread to make the dough rise. Ammonia and baking soda used for cleaning and removing grease. Bleach used for removing stains and disinfecting surfaces. Chlorine and activated carbon can help purify water, making it safe to drink. Coconut oil used in shampoo and other skincare products. Biodegradable materials such as food waste are used in making compost to enrich the soil. The use of biodegradable materials reduces waste, thus preventing environmental pollution and supporting sustainable practices. Compostable plastics are used as alternatives to traditional non-biodegradable packaging materials. Fibers from rice, corn husks, sugar canes are used in making single-use food containers. These food containers are used in the food service industry. Some construction materials are now being made from biodegradable materials. Fibers from rice, corn husks, sugar canes are used in making boards and building insulation materials, which help make building more environment-friendly. Let us do activity number 1. Determine the practical uses and applications of materials based on their chemical properties. Write your answers in your notebook. Let us do activity 21. Using reliable books, magazines, or the internet, research the procedure on how to make a simple compost bin. Then, make your own compost bin at home with the help of an adult family member. Answer the guide questions on your notebook. Study the diagram. From the information presented in the diagram, form sentences that state important things you have learned in this lesson. Write the sentences in your notebook. For your reflection, copy the table below in your notebook. Read each statement carefully. In the second column, write, yes if the statement is 100% true and you have no more questions, somewhat if you still have some questions or areas to review, or not yet if you need further clarification or require more time to revisit the lesson.